Harry from GMAT Ninja here, and in today's video we're going to be talking about inequalities and absolute values. Now these are two topics on the GMAT that people tend to find difficult or maybe just a little intimidating, and so I've got 7 questions today to work through the fundamental processes underpinning them all, and then to show you how the GMAT will ask these questions, so that by the end of today hopefully you'll find these topics a little easier and know what to expect when you're sitting your GMAT exam. Now like I've said, there's 7 questions. The first 4 of them where we go through the fundamentals, how to deal with an inequality, how to deal with an absolute value, and then how to deal with them together. These questions are going to be on the slightly easier end of the scale, somewhere between a 75 and an 80 on the Quant scoring scale. Question 5, we're going to turn the difficulty up just a little bit. That's going to be a little bit over an 80, and then question 6 and 7, that's when we're going to try and stretch things a bit and really get into the 80s and show you what the GMAT can do with these topics. All right, now in here there are 2 data sufficiency questions. We know that data sufficiency has moved to the data insight section, but it still uses the same concepts, the same content, and so we're doing some data sufficiency questions in our Quant series as well. All right, having said all that, I'll get the first question up on the screen. We'll give you a couple of minutes. We'll take a look at the solution afterwards. So take 2 minutes and check this one out.
Hey everybody, Charles here. Sorry for the interruption. Before we get you back to that Quant content, 3 quick things I'd love for you to be aware of. First of all, this video is part of our full, free, complete GMAT course that's available up on our YouTube channel. If this course is saving you money that you would otherwise spend on a course or a tutor, please consider donating some of that savings to charity, either a charity that you love. If you don't have a charity that you love, we've got a list of charities that we love to support on our website, gmatninja.com. Second thing, if you love that presenter that you're watching in this video, not me, the other one, they offer one-on-one tutoring. If you're interested in that, gmatninja.com and we can set you up. Third thing, finally, if you're doing great on the GMAT, doing great on the GRE, starting to look for admissions help with your applications for grad school, we would love to refer you to a bunch of our favorite companies. So just hit us up. There is a contact form on our website, gmatninja.com. Also, a link in the video description. Just fill that out. We'll send you a list of our favorite admissions consultants, not just at our company, no strings attached, not gonna sell your email, not gonna try to sell you anything. We just wanna make sure if you've put in the hard work on the GMAT, that you end up in the best possible hands if you need help with your applications. All right, that's it. Enjoy the Quant.
All right, hopefully that's been enough time to take a look at question 1. But as always in these videos, if you need a bit more time, here's your chance. Pause the video, go back to the question. You know where we are. We'll still be here going through the solution whenever you're ready. All right, question 1 then. What I want to do is really take time and break down how to deal with absolute values here so that we can use this later on in the videos. All right, so we've got this equation, 3 times the absolute value of 2x minus 3, take away 5 is equal to 28. Now, first thing I want to do is I want to treat this absolute values, the whole thing, the absolute value sign and what's in it, I want to treat that as sort of like a variable, like an x in an equation. I want to get it on its own on one side of the equation, and then we'll worry about what's inside it. So given this, I'm going to add both sides, add 5 to both sides of the equation to begin with. So I've got 3 times absolute value of 2x minus 3 is equal to 33. And then I'm going to divide both sides by 3 to give me absolute value of 2x minus 3 is equal to 11. So there we go. I've got the absolute value sign on one side on its own. That's sort of phase 1 of this solution done, and now I can go into phase 2. So just as a bit of an aside, I want to look at what an absolute value sign does, because it does 2 different things depending on whether what's inside it is positive or negative. So I'm just going to use 6 and negative 6 here just as an example. If what's inside the absolute value sign is positive, then that absolute value sign doesn't really do anything. You could think of those vertical brackets as just a standard set of parentheses. It just doesn't do much. If what's inside the absolute value sign is negative, so in this case the absolute value of negative 6, well then the absolute value sign takes the negative thing and makes it positive. Now I'm going to put a step in the middle here. We wouldn't need it for this, but we're going to use it later. You could think of the absolute value sign as becoming a set of parentheses, and then we just stick a minus in front of it, a minus 1. And so we get minus 6, and that gives us the positive. All right, now we're going to take that and use that in this more complex case. Now the problem is here, I don't know, because I don't know what x is, I don't know whether 2x minus 3 is positive or negative. So we've got to look at both cases. All right, so we've got to consider what happens if 2x minus 3 is greater than or equal to 0, and we've got to look at what happens if 2x minus 3 is less than 0. So we'll do both of these separately. We'll come over here on the left-hand side first. So if 2x minus 3 is greater than or equal to 0, then 2x is greater than or equal to 3, and x is greater than or equal to 3 over 2. Right, now that's not done anything. That's just given us the condition we need to come down this side. All right. Now, I know that this question says that if x is less than 0, but again, just because this is the first question, just because we're going through how these work, I'm going to finish this side off here. So if x was greater than or equal to 3 over 2, then what's inside that absolute value sign is positive. And so just like we had with the 6's and the negative 6's, the absolute value signs almost melt away because that set of parentheses doesn't do anything. And I get this fairly simple equation here. I can add both sides, add 3 to both sides, divide by 2, and I would get x is 7. Now, final check. What we need to do is just say, well, this x is 7 must be consistent with this condition. So we said we can only come down this path if x is greater than or equal to 3 over 2. This told us x is 7. Great, 7 is greater than 3 over 2. We're okay. There are very rare occasions when these two might disagree with each other. Let's say we got x is negative 7. We didn't, but let's just say we got x is negative 7. In that case, you just sort of cross this side out and just go, that's not a solution here. Again, very rare, but it happens. All right, back into this question. Like we said, x is less than 0. We couldn't even come down this path. X is 7. That's not a solution. We don't have to worry about this. Let's take a look at this other side. All right, exactly the same way. I've got this inequality. That's the same as saying if 2x is less than 3 or if x is less than 3 over 2. So if x is less than 3 over 2, we can come down this path. And what happens then is we've said what's inside the absolute value sign is less than 0. Now what we can do when it's less than 0 is turn the absolute value sign into a set of parentheses and stick a negative sign in front of it, and then just treat it like normal algebra. So minus times what's inside this, expanding this parentheses, we get negative 2x plus 3 is equal to 11. So negative 2x is equal to 8. Divide by negative 2, I get x is equal to negative 4. Quick check. Is x equal to negative 4 consistent with the condition that we used to come down this path? Yes, because we come down if x is less than 3 over 2. Well, x is negative 4 is definitely less than 3 over 2, so we're good on that front. X is less than 0, well, negative 4 is definitely less than 0, we're okay there, which means that x is negative 4, or C, is the answer to this question. All right, I know I did a bit more work than was necessary here to get through that, but I wanted to sort of go through this is how to deal with an absolute value equation, just in case you need to somewhere else. All right, let's get question 2 up on here. Take a couple of minutes and we'll check back in with the solution after you've had a chance to look at it. Okay, question 2, we've done a bit of absolute values in question 1, now we're looking at inequalities in question 2. And this, admittedly, even though I said that this is not the toughest one, this looks horrible. I'd appreciate if this was intimidating as a question to begin with, and really that's where these topics go. The algebra, as I hope we'll see in the next few minutes, is not that bad. It's just these questions look horrible to start with. All right, so what we're given this cx plus 2 is greater than cy, and then we're asked, okay, which of these must be true? Now, these look like manipulations of what we were given to begin with, and so really the question is, well, can we get there? And, well, no, more than that, do we have to get there if we manipulate these things? Basically, is 1, 2, and 3, is that equivalent to number 1? Now, a lot of this comes down to how can you deal with inequalities. So let me get this written up here. So cx plus 2 is greater than cy. And we're starting to compare what we were given to what we're looking for. Now, with inequalities, I can add and I can subtract and I can multiply and divide by positive numbers, and I can treat the inequality sign basically like an equal sign. It doesn't make much difference. The thing that I need to look out for, and really this is the key to this question, is have you multiplied or divided by a negative number? Because if you multiply or divide by a negative number with an inequality, you need to flip that inequality sign. So I'm going to start with number 1. We're going to take a look at what we were given, and just take a look at number 1 and go, well, what have we done? What would we need to do in order to get there? Now, the big key here is to see that, well, I had cx and cy, now I've got x and y, and I just had a 2, and now I've got a 2 over c. So really what we would need to do in order to get from here to here is divide by c. So if I do that, if I divide by c, great, x plus 2 over c, divide by c, I'm going to get y, but c, do I know whether that's positive or negative? Should the inequality sign stay the same? Is c positive? Or should the inequality sign flip around? Is c negative? Well, from the question, from the information given, I don't know. I have to assume it could be either. And if you look here, well, this now, I know I said I was looking at number 1, but this now looks like number 2. I flipped the inequality sign around and it looks like number 2. If I kept it the same, and then move the 2 over c over to the other side, then it looks like number 1. So number 1 comes about if I divide by c and c is positive, and then I do a bit more manipulation. Number 2 comes about if I divide by c and c is negative. But but I don't know. I don't know whether C is positive or negative. So from this, because the question is which of the following must be true, it's not number 1 and it's not number 2. If the question had said which of the following could be true, then yeah, number 1 and number 2 could be true. Well, C is just a number. If C is positive, then number 1 is true. If C is negative, then number 2 is true. I don't know whether C is positive or negative, so we can't say it must be true. We don't say it have to be true. All right, now number 3, the C is still on the top line of this equation. So we've not divided by anything. Okay, so maybe I'm safe here. Let's go back to the start. Let's take this and just play around with it and see if this has to be true. All right, now 3 has a 2 on the other side, so let's take that 2 to the side, and it has all the y's on the left-hand side, so let's bring that across to the left-hand side, and then factor out the C, and I get from the start point to what's in number 3, I haven't had any of that, well, something positive or negative. I haven't multiplied by a negative number or something that could be positive or negative. I haven't divided by them. I've added things to both sides. I've subtracted things from both sides. I've factored out a common factor of C there, but that's okay. Even though I don't know whether C is positive or negative, I haven't multiplied or divided the whole inequality by that. So we're fine. This, number 3, is just an equivalent way of writing what we started with without worrying about whether it's positive or negative, or sorry, whether any of the variables are positive or negative, or whether we've multiplied or divided by them. And so we can say that number 3 must be true from our starting point, which means that C is the answer to this question. All right, so when you're dealing with inequality signs, you can add, you can subtract, you can multiply or divide by a positive number and treat that inequality sign just like an equation. It's when you start multiplying or dividing by a negative number, that's when things get complicated, and you've got to remember whether to flip that inequality sign. The key to some of these questions on the GMAT is, do you know whether this variable, in this case it was C, do you know whether that variable is positive or negative? In this case we didn't, so we can't say that number 1 and number 2 must be true, even though they could be true. We can't say they must be true. All right, we have separately looked at absolute values in question 1, we've looked at inequalities in question 2. Now let's push them all together in question 3. So next question is going to be up on the screen. Take a couple of minutes and have a look at this one. All right, question 1, we had absolute values by themselves. Question 2, we had inequalities by themselves. Now we're pushing them together. So as we said, difficulty level, intimidation factor, possibly increasing a little bit. Now this is one of those questions where there are several ways of getting to a solution here. I'm going to show definitely two, maybe more. We'll see how this goes. There might be other ways, there might be more efficient ways, but so if you've got a different solution, feel free to punch them into the comments below. But what I want to do here is first of all go through the algebraic way of doing it so that you know what's going on in the background. Then we'll look at maybe a couple of shorter routes to get to the answer here. So I'm going to start with A and say, well, okay, we've got the absolute value of x plus 3 and that's less than 4. Right, so in question 1 we looked at how to deal with absolute values in equations. Now we're doing something similar, but we've got an inequality going on here. To begin with, we've got the absolute value sign on its own on one side of the inequality. Great, so we don't have to do any work beforehand like we did in question 1. We can jump straight into that phase 2. And from here it's very similar. I'm looking at what's inside the absolute value sign and splitting this down into two paths. What happens if what's inside the absolute value sign is greater than or equal to 0? And what happens if it's less than 0, because in those two cases the absolute value sign does different things. So over here, if what's inside the absolute value sign is greater than 0, or if x is greater than -3, then x plus 3 is positive. So just like we had in question 1, the absolute value sign basically melts away. It becomes a set of parentheses. So x plus 3 is less than 4, and we can say, well, x is less than 1. Right, again, back to just checking in that our answer matches up with our condition, and in this case things are slightly different. I've got x is less than 1, I've got x is greater than or equal to -3. I can put those together and say that this side will work, or this side says that this works for -3 is less than or equal to x is less than 1. So we bring these inequalities together. Similar scenario over here, right? X plus 3 is less than 0, so this works if x is less than -3. Now, that says that what is inside the absolute value sign is negative. So just like in question 1, we change the absolute value sign to a set of parentheses and stick a negative sign in front of it. And the reason for doing it this way is it means that I don't have to remember whether or not I'm flipping my inequality sign. I can just keep it the same way around. Now I can go through this question, multiply out the parentheses, so -x minus 3 is less than 4. I'm actually going to take the x to the right hand side here and say, well, that makes -3 less than 4 plus x, and then subtract x from both sides, so x is greater than -7. Now again, I'm going to bring these together. This one says x is less than -3, this one says -7 is less than x, so -7 is less than x is less than -3. Final step, I can bring these together and say, well, look, this one deals with -7 is less than x is less than -3, and this one, -3, is less than or equal to, so I've got that -3 included here, is less than x is less than 1. So I can sort of bring these two together and push them together into a single inequality and say, well, that's -7 is less than x and is less than 1. And so I've got an algebraic solution here. Now, in this case, this goes from -1 up to 7, whereas this is -7 up to 1. So A is not the answer. We can say that outright. But at least, look, this will hopefully have shown you how to deal with an absolute value and an inequality together. And in this case, we broke it down and we ended up with a single inequality down at the bottom. All right, now, there are better ways of answering this question, so let's look at this slightly differently. Again, I'm going to stick with x plus 3 is less than 4. Now what we can say, what an absolute value sign does, I'm going to write it up like this. Now this tells me that the distance on a number line between x and a is less than b. All right, now we can put some concrete numbers into that to make that work. I'm still going to use a. You'll notice here that this is a negative and this is a positive, so I've got to do a bit of playing around with this. For x plus 3 less than 4, I can say that that's the same as x take away -3 is less than 4. And now this says, A says, the distance between x and -3 is less than 4. So let me draw a bit of a number line here and we can see what happens with this. So if I put -3 in there, now I said the distance between x and -3 is less than 4. So let's go 4 this way and 4 this way from -3, and I'm going to get -7 and I'm going to get 1. and the distance is less than that, so the distance between -3 and x is less than these, and so I would get a shaded area that looks like this, which thankfully, as it should do, matches up with what we found by the algebraic solution. So -7 is less than x is less than 1. And so, again, we can do this both ways. We could go through the full algebraic route for all answer choices. We could look at each of the answer choices and figure out the interval, or we could almost reverse this. The thing I want you to notice here is -3 is exactly halfway between -7 and 1. So if I come up to our graph that we were given in this equation, well, what's halfway between -1 and 7? Well, that's going to be 3. So the final answer that we're looking for here is definitely going to have an x minus 3 in it. Again, remember the sign flips here, x minus 3, the distance between x and 3. So in that case, we've already crossed out A, but we can definitely cross out B as well. And now we're dealing with C, D, and E. Now you'll notice that C has the greater than sign, whereas D is less than or equal to, and E is lesser than. Right? In this case, what we're saying, this shaded bit is less than, so we're putting an upper limit on it. The distance x is going to be sort of x could be here, x could be here, x could be here. The distance between x and 3 is definitely within these boundaries, and 7 and 1 are 4 either side. If C was right, then we would have shaded the outside bit. We'd have shaded out here and not shaded the inside bit. So it's definitely not x minus 3 is greater than 4. The distance between x and 3 is going to be either less than or equal to. And now the difference between D and E is whether these bubbles at the end are shaded. If they're shaded, then -1 and 7 are included, and it's less than or equal to, which is what we have here. These are shaded in, so we want less than or equal to, not less than. So the answer to this question is D. All right, a lot going on there. I know I did several different ways of doing this. This is how to think about algebraically if you've got an inequality and an absolute value sign. This is how you can think about it a bit more graphically, or when we're given the graph, we can reverse engineer this in order to come to the solution. All right, so hopefully that's given you a few things to think about. We've got one more question where we're sort of thinking about how does the fundamentals of inequalities and absolute values signs work. So I'm going to get this question up on the screen. It's a data sufficiency. There's a few more words here, so this is possibly going to be a bit more difficult than the first three we've seen. Hopefully not too much of a challenge. Take a look. I'll see you back here for the solution soon. Okay, back to straight inequalities here. So there's no absolute values in this question, but data sufficiency, and there were a lot of words in that question. You can see I've already shortened things down here. So difficulties coming at you from different places and different questions here, but let's jump in and see what we've got to work with. So the question starts by telling us that this door just sells clothes in 4 sizes. So we've got small, medium, large, and extra large, and I've shortened those to S, M, L, and X. And the question that we're really asking here is, last year, did this store sell more small than medium items? So the question we're working with is, were the number of small items sold greater than the number of medium items sold? Nothing else we can really do with that question. I can't push the question any further, so we're going to have to get into statements 1 and 2 and see what we can work with here. So statement 1 tells me that last year the sum of the number of medium and extra large items sold, so the sum of the medium and the extra large items sold, was less than the sum of the number of small and large items sold. All right, I've got small and medium on opposite sides of the inequality, but I've also got X and I've got L in here, and I have no idea what those are. This is just not sufficient here. There's too many variables. I can't do anything with this that would get me to figure out whether the number of small items is greater than the number of medium items sold. So cross out A and D. We can do something similar with statement 2. So the sum of the number of small and extra large items sold, so small plus extra large items sold, was greater than the sum of the number of medium and large items sold. So I can say S plus X is greater than M plus L. And then in a similar way to statement 1, I'm looking at this and going, well, I've got S and M on separate sides of this, but I've got an X, I've got an L, exactly the same as statement 1. It's just not going to be sufficient to deal with here. Now, putting statement 1 and statement 2 together, on the surface of it, straight away, I'm again looking at these two going, there's an awful lot of variables here. I've got 4 variables, I've got 2 inequalities. That it doesn't make me confident I know where this is going. But look at the inequality signs being the other way around here. At the very least, to bring them together, I'm going to get these 2 inequalities together so I can compare them, and I'm going to have the inequality sign facing the same way. So let's take this one. From statement 1, I've got M plus X is less than S plus L. And from statement 2, I'm going to turn this inequality sign around and say that, well, that tells me M plus L is less than S plus X. And now what I can do is notice, well, I've got an X on the left-hand side here and on the right-hand side here. And I've got an L on the left-hand side here and on the right-hand side here. I can do something a little sneaky. I can treat these as simultaneous inequalities, and I can add the 2 inequalities together. Now, just so that you can see what's going on, we'll come over here. If I had 2 inequalities, if I said 6 is greater than 4 and we'll have 5 is greater than 2. Right, so both these inequalities, obviously, they're just numbers. Yeah, 6 is greater than 4, and yeah, 5 is greater than 2, no problem. What I can do with these, I can add these 2 lines together. 6 plus 5 will give me 11, and 4 plus 2 will give me 6, and the inequality sign is still pointing the same way. And 11 is definitely greater than 6. That works, no problem there. What I can't do is subtract inequalities, because if I try and do that, if I do 6 minus 5, that'll give me 1, and 4 minus 2, that'll give me 2. But the inequality sign still points the same way, and this says that 1 is greater than 2, and which definitely doesn't work. 1 is definitely not greater than 2. So when you're dealing with simultaneous inequalities, we can add the 2 lines, but we can't subtract one away from the other. So let's take a look at what happens if I do add these 2 lines together. Okay, M plus M, I'm going to have 2M, and I've got a plus X and a plus L. Keep the inequality sign the same way around. S plus S will give me 2S. I've got a plus X and a plus L. Well, I could subtract X from both sides of this inequality. I could subtract L from both sides of this inequality. And what I'm left with is 2M is less than 2S. Okay, divide by 2 on both sides, so M is less than S. 2 is a positive number, so I don't have to worry about flipping the inequality sign around. And I've got M is less than S. We'll go back to the question I was asking, is S greater than M? Well, S is greater than M. Yes, I can tell from both statements together. I can tell that C is going to be the answer to this one. Both together are sufficient. Answer to this question is going to be C. So yeah, with inequalities, again, I've got 4 unknowns, S, M, L, and X, but I've only got 2 equations. But because of the way they were set out, I could put them on top of each other, make sure the inequality signs were the right way around, and then by adding them, and I can only add them, I can't subtract them, by adding them, In this case, the X's and the L's disappeared and I was left with something I could work with. So in a question like this, when the inequalities look like you can't do anything with them, one of the things you can test out is just put them on top of each other, get the inequality signs lined up. Can you add them? Does something work from there? All right, those are the 4 questions where we're looking at sort of the fundamental principles, the processes that you need to know in order to be able to answer a question on inequalities or absolute values. Now what we're going to do is start sort of making these questions more and more GMAT-like, turn the difficulty level up a little bit. So this next one, another data sufficiency question, it's going to be a little bit more difficult. Take a couple of minutes and have a shot at this one. Okay, question 5 here, we're getting into some more difficult stuff. Let's take a look at the question and see what information we can glean from it before we get into the data sufficiency process and worry about what's in number 1 and number 2. So we've got these 2 people who are in sales for a large company. We know they received 10% commission. And the question is, who made more commission last year? So the question is, let's say, which is bigger, 10% of Adesh's sales, because that's what he receives in commission, or 10% of Belmira's sales, because that's what she receives in commission. Now, what I hope you're noticing here is the 10% doesn't really make much difference to the outcome of the question. Because they both receive the same commission, this is really who sold more, Adesh or Belmira. So if we know the total of their sales, then we're just going to take 10% and that's what they receive as commission. So if Adesh sold more than Belmira, then he makes more commission. If Belmira sold more than Adesh, then she makes more commission. So this question is, while it's about commission, it's really about sales too. All right, so I can't push the question any further. Let's look at the information we can get from statement 1 and statement 2 and see where we go. So statement 1 first. Adesh sold more than $1.2 million worth of goods in March. So Adesh's March sales were greater than 1,200,000. Similarly, Belmira's September sales were less than 800,000. Right, I'm using A and B for Adesh and Belmira, and the subscript M there is for Adesh in March, and the subscript S there is for Belmira in September. But from this, if we want to know the total they sold across the year, knowing what each of them sold in a single month, and different months with that, Adesh is in March, Belmira's in September, that's not going to help us answer who sold more overall in the whole year. So we're going to cross out A and D, and that's not going to be the answer here. All right, number 2, so Belmira made more than 1/6 of her sales in September. So Belmira's September sales were greater than 1/6 of her total sales. And similarly, but the opposite way around, Adesh's March sales were less than 1/4 of his total sales. So his sales in March were less than 1/4 of his, sorry, I've got my letters all muddled up there. Adesh's made less than, in March, made less than 1/4 of his total sales. That makes much more sense. So Adesh in March made less than 1/4 of his total sales. Right, now again, I've now got 4 variables. I've got B, and I've got B in September, I've got A in March. Using statement 2 alone, I can't do much with this to figure out, well, what's bigger, A or B? I can't combine these two inequalities in the way we could in the last question. I can't put numbers to them. Statement 2 is not going to be sufficient by itself. All right, bringing these together, what I hope you're noticing here is I've got Adesh in March and Adesh in March. I've got Belmira in September, I've got Belmira in September. So let's look at the way we can use these. I'll do Belmira first just because she's on top row here. I've got Belmira in September. Now, if you look at the inequality signs, these are all pointing the same way. 1/6 of B is less than Belmira in September, but Belmira in September is less than 800,000. So what I can do is I can bring these two inequalities together and almost stack them left to right and say, well, Belmira in September is less than 800,000. Belmira in September is less than 800,000. And from there, I can say, well, I've got 1/6 of B is less than Belmira in September is less than 800,000, which means that I can almost just ignore the middle bit and say that I know that 1/6 of B's total sales, Belmira's total sales, is less than 800,000. Or in other words, just rewriting that, 1/6 of B is less than 800,000. So B is less than 4,800,000. And I can do a similar thing down here with Adesh's. So Adesh in March was less than 1/4 of A, but Adesh in March was greater than 1.2 million. This is possibly a little more difficult to see because the inequality signs are pointing the other way around. But what I can do is say that Adesh in March was greater than 1,200,000. And again, I've got this sort of 3-way inequality here. I've got these 3 items. And when you've got that, we can ignore the middle and say that 1/4 of Adesh's total is greater than 1.2 million. So rewriting it in the same way we did with Belmira, we can say that 1,200,000 is less than 1/4 of Adesh's total sales. So Adesh's total sales are greater than 4,800,000. And so from this, Adesh is greater than 4.8 million, Belmira is less than 4.8 million. So by taking these two statements together and by stacking these inequalities left to right, one on top of the other, from both statements together, we can say Adesh sold more than Belmira, which means that the amount he received in commission was more than Belmira's. So from the two statements together, I can answer the question, and so the answer here is C. All right, so we're bringing together all these different little things you can do with inequalities and absolute value signs. Last time we could add 2 simultaneous inequalities. This time, while we've got 2 inequalities that work together, we're not adding them, we're just sort of stacking them in line and then ignoring the bit in the middle so that we can work with the bits on the edges. All right, like we said, the difficulty level is going to step up a decent chunk here. Question 6 should be tough. This is well into the 80s now on the difficulty level or in the score scale. So take a couple of minutes, have a shot at this. All right, we're into some difficult stuff now. We've got absolute values, we've got inequalities, we've got an equation with a fraction in it, we've got all sorts going on. Yeah, this is where things start to get tough. Now, as with a lot of these questions, one of the things to think about is your first reaction the best way to do this? Because like, if I looked at this, I'd be like, hey, we've just been given some algebra. Let's just go headlong and see if we can solve the algebra. And honestly, in this question, that's going to get really tough. What we need to do here is just sort of take a step back and just have a think about what we can do with this. And so I'm going to split this question up into a couple of different scenarios here, based on what we were given to begin with. So I want to know when this left-hand side, this horrible algebra-filled left-hand side, when that's less than or equal to 0. So first, I'm going to take a look at what happens when this left-hand side is equal to 0. I'm going to ignore the less than for now. We're going to deal with the equals to 0 bit first. Now, when I've got an equation like this with a fraction, and the fraction equals 0, then all we really need to look at is when does the top part of that fraction equal 0? Because 0 divided by anything is still going to be 0. Now, just to be careful, I'm not looking for what happens when the bottom part of this fraction equals 0, because something divided by 0 does not equal 0. It's undefined. Try it with your calculator. Your calculator will just throw back an error message at you. So in this case, I could ignore the bottom line of that fraction, and this is just saying what happens when x minus 4, absolute value of x minus 4 multiplied by x plus 5 equals 0. In this case, because I want these to equal 0, the absolute value sign is not doing much there. This whole thing will equal 0 when x is equal to 4 and when x is equal to negative 5. So I've got two solutions to this. The question is how many integer values do satisfy this. I've got two of them already. Now let's go and separately take a look at what happens when the absolute value of x minus 4 multiplied by x plus 5 over x plus 1 when that's less than 0. Now here too, I don't want to dive head first and go into the algebra here. I want to sort of see if we can find a way around this. Now in this, I've got three things. You could think of the absolute value sign and the two sets of parentheses as separate things. And I've got three things. I'm going to multiply two of them together on the top, then I'm going to divide them, and the output needs to be less than 0. So when I've got three things, there are sort of different scenarios where that could come out to be less than 0. I could have all three being negative, or I could have two positive and one of them negative. Now, the absolute value sign puts a bit of a limit on that, because the absolute value sign, what comes out of it, can't be negative. It could be 0, but we've dealt with that over here. So on this side, we're saying, well, what's coming out of the absolute value sign, that must be positive. Which means that of the two we've got left, the x plus 1 and the x plus 5, one of them needs to be positive and one of them needs to be negative for this whole left-hand side to be less than 0. Now, I don't know what x is, but if we put this on a number line, x plus 1 would be to the left of x plus 5. Like if I take a number and add 1 to it, and if I take the number and add 5 to it, the one where I add 5 is going to be to the right on the number line than the one where I add 1. Now, if one of these needs to be positive and one of them needs to be negative, then 0 is going to be somewhere in between. Or in other words, what I'm looking at is x plus 1 is less than 0 and x plus 5 is greater than 0. And now I've got two quite nice inequalities. I can go and solve these. This one tells me that x is less than negative 1, and this one tells me x is greater than negative 5. And now bringing these two inequalities together, this tells me that negative 5 is less than x is less than negative 1. And now the integer values that satisfy this would be x is equal to negative 4, negative 3, or negative 2. So I've got three values there, two values here, total of 5 integer values that make this inequality work. And so the answer to this question is 5. Right, so what we got here was that the actual algebra that we did was not that hard. And sort of I did a bit of sort of quadratic solving, and we solved two relatively simple inequalities. But it was the thinking and the getting to those points that's the difficult bit. As I say, if you're looking at something like this, and again, as we said at the start, big part of the difficulty in these topics is just the intimidation factor is what really gets you before you even get going. If you dive at your first thought and think, hey, this is just an equation, I can algebra my way out of this, that's when you're going to get in trouble. See if you can think of a way around this. See if you can think about the situation that you're dealing with and that might make the algebra look a lot nicer once you get into the question. All right, we've got one more question coming your way, and the intimidation factor is really going to step up even further. That's where the difficulty is going to come in this final problem. So don't get intimidated. Have a think about what you've been given. Think about all the stuff we've gone through, and take 2 minutes and have a shot at this.
All right, 2 last things. Thank you so much for making it to the end of the video. If you've made it this far, you're one of those awesome people that's obviously really engaged in this GMAT thing. We would love your comments and your feedback. If there's anything else you'd love to see in our videos, hit us up in the comments. We'll do our best to oblige. Second thing, if you're enjoying it, hit that like button, hit the subscribe button. Helps other test takers like you find our full free video course. You need anything else? You know where to find us, gmatninja.com. Thanks so much. Enjoy this last question.
All right, final question for the day. And if your first thought was, I just want to run for the hills, I don't want to deal with this, then I wouldn't blame you. This question looks horrible, looks awful. But let's see if we can use some of the things that we've been talking about today to break this horrible expression down, make it look simpler, and see if we can get to one of the answer choices. So, great big horrible thing, but I also know this. P is greater than Q is greater than R. And I'm going to deal with this bit by bit and just see if we can simplify things and see where we can take it. So just working left to right, let's start with this first bit. Absolute value of P minus Q. All right. Now, 3 scenarios we really need to think about, because I don't know where 0 is in this inequality. We could have P and Q both positive, we could have P positive and Q negative, or we could have P and Q both negative. Now, what we can say, look, if they're both positive, and I'm not going to put some numbers to this, we've done this a couple of times in this video, so if you want to, pause the video here and check these scenarios as we go. But what we can say that if they're both positive, P is bigger than Q, so what's inside the absolute value sign, the P minus Q, that will be positive. If P is positive and Q is negative, I've got a positive number, take away a negative number, the output's going to be positive. Final one, if P is negative and Q is negative, but Q's smaller, so Q's more negative, then P minus Q again will be positive. What's inside this absolute value sign in any of those 3 scenarios will be positive. And when, as we've seen so far, what's inside the absolute value sign is positive, the absolute value sign doesn't really do much. We can replace it with a standard set of parentheses. All right, now moving left to right again, the next bit I should really pay attention to is this, the absolute value sign of R minus Q. Now I'll put this down here just so that we can talk about that. Now what we know here is that Q is greater than R. So this is almost the reverse. The first time when we had P minus Q, it was the greater number subtracted from, the smaller number subtracted from the greater. Here we have the greater subtracted from the lesser. In this case, if Q and R are both positive and Q is bigger, then what's inside the absolute value sign will be negative. If Q is positive and R is negative, well then I've got a negative number, take away a positive number, that'll still give me a negative number. Finally, if these are both negative, then I've got a negative number, take away a smaller negative number, although that will come back towards 0, it will never reach 0, this will definitely still be negative. Again, if you want to test that out using some actual numbers, feel free to pause here and we'll still be here when you've had a chance to check that. But what we can say is that R minus Q will definitely be negative. And as we've seen, when you're dealing with an absolute value sign and what's inside the absolute value sign is negative, I can rephrase that as negative R minus Q. Now in this case, we're sticking a negative sign. We've got to take away negative R minus Q. So these two, the negative negative will become a positive there. So we can erase this and now we can simplify our expression a little bit more. I have the absolute value of P minus Q plus R, take away the absolute value sign of P plus R minus Q. Right now, let's take the left-hand side just because it's first in line, but let's look at this one first. As we said, P minus Q is going to be positive. We've dealt with that. And now I'm going to add R on. But now we hit a bit of a difficulty. Look, if R is positive, then P minus Q plus R, great, that's going to be positive and we're out of here. But we don't know that. It's possible that sort of, I don't know, let's say P is 10, Q is 5, and R is negative 1,000. In which case, what's inside this absolute value sign will be negative. But if P is 10 and Q is 5 and R is 1, then what's inside is positive. So I can't take this any further. I've got P minus Q plus R, and I kind of have to leave it there. Now on this side, if I just rewrite this, I've got P, I've got a minus Q, I've got a plus R, I can have the same discussion that I had here. And we can say, look, I've got this thing, don't know whether it's positive or negative, this thing, don't know whether it's positive or negative. And so I can't get rid of these absolute value signs, but I can look at this and go, well, I don't know what's going to be in here, but whatever it is, the absolute value sign is going to do something to it, but it's going to be the same as this one because these are the same. Whatever's inside the absolute value sign, if it's positive, absolute value sign will disappear, absolute value sign will disappear, P minus P will be gone, and so on. Whereas if what's inside this absolute value sign is negative, the absolute value sign will make it positive. Same over here, I'll get a positive number, take away the same positive number, it's going to disappear. I don't know what's inside it, I can't do any more, but I've got this thing, take away the same thing, the whole thing's going to equal 0. And so the answer to this question is 0, it's A. It just, the whole thing collapses very nicely at the end of it, and we get an answer of 0 here. All right, so yeah, as I hope you're starting to see with these questions, the difficulty comes a lot in how difficult they look up at the start. And if you can think about them, if you can find a way in, if you can simplify the problem just that little bit, they tend to not take too much work, not too much algebra in order to get to an answer here. All right, so yeah, there's the 7 questions for today. What I hope that we did there was, first of all, show you the processes you need in order to be able to answer these questions on the GMAT, and then to give you an idea of how to think about these problems, especially when they get really difficult and really intimidating, so you can find a way in. And once you've found a way in, then the ball's rolling and you can hopefully get to an answer. All right, I hope you found this video helpful. If you have done, please hit that like button, please hit that subscribe button, and we'll hopefully see you back here at another one of our videos very soon. Have a great day, everyone.